Okay, hi guys. So in this lecture, we'll be starting off with, or rather, continuing with examples of Grignard reagent. Okay. So we have something like this. Let's look at the first example. We have something like this, and we are passing another RMGBR or Grignard reagent in it, and that too in excess, providing acidic medium. So what would be the product? Obviously, this would be first attacking on this carbon atom. So we would get something like O minus Mg plus Br, and we'll get CH3 here and OET here. Again, what will happen is this organic oxygen would again form a double bond, and we'll get something like this with the release of OET minus. Again, as CH3 MgBr is in excess, this will again react on this, add itself on this carbon. Again, we would have something like this, O minus Mg plus Br, and we'll get something like 2 CH3s attached. Okay. Again, we would get something like this, wherein oxygen atom actually forms a double bond with the carbon atom, and with the release of this leaving group. So we get something like this. Again, CH3 MgBr is in excess. What will happen is, again, it will attack on this slightly positively charged carbon atom, and again we'll get something like this, O minus Mg plus Br, and we have acidic medium in place, so this O minus will get itself attached to this. So this will be the final product formed. Okay, let's look at another example where we have something like this, and OET plus, here we have x moles of CH3 MgBr. So you have to determine the value of x, and here we are slightly more concerned about how many moles are required. So we won't be passing excess of CH3 MgBr or excess of Grignard reagent. We want the exact value of x. So hence x would be number 3. Why? The first CH3 MgBr will attack on this. This will remove OET minus. Okay. Second MgBr will be helpful for removing. Sorry, this will again be acting on this carbon atom only, but in the second time, again it will help in removing the Cl from the carbon bond. Okay, and again till now we have C double bond O and 2 CH3 attached to this carbon atom. Then again we need a CH3 to attack on this to form O negative here, and then H minus or H plus rather would be attacked by oxygen atom. So finally we would have something like this, 1, 2 and 3 CH3s would be in place. Okay, so total number of x would be 3. Okay, I hope you followed this example. Now let us say we have something like this, double bond O, and we react it with CH3 MgBr, obviously in presence of or in acidic medium. So what would be the product? We would have something like this, CH3 MgBr would be actually be acting on this carbon. So we would have something like O minus, and we'll have CH3 here, obviously Mg plus and Br minus here also. Now next we would have another CH3 MgBr. I forgot to mention it is in excess. If excess is not mentioned, then only consider 1 mole is present. CH3 MgBr again. So now what will happen is, or rather I have not shown the complete picture. So this would come into the picture only when this again forms double bond and it leaves the bond between this carbon and itself, this oxygen atom. So we would have something like double bond O. We are talking about this carbon atom, now this carbon atom, now this carbon atom, now this carbon atom. Finally we have O minus. Okay, now again we have I forgot to erase it. Now again we have CS3 mgbr as it was provided in excess quantity. So again we have CS3 mgbr. Now what will happen is we have something like, again the attack would be there on this carbon atom. We get O minus mgbr. Okay, now we get 1 2 3 O negative here as well. So now there is no scope of leaving group. This is the poorest leaving group, carbon CS3. I don't know whether I mentioned in some previous lecture or not. CS3 will not act as a leaving group. By CS3 I mean R only, means starting from CS3 and we can have R also. Okay, so now we are having acidic medium also in place. So our final product would be something like this. This would be our final product. Okay. Okay. One thing to remember in place, that in real world scenario, once the acidification takes place, then the Grignard is actually removed from the reaction. Why? Because if the Grignard is present even after that, then it will act as a base and will also take this acidic hydrogen from itself, okay, and form methane. So one important point to note here is, once the acidification takes place, Grignard is removed. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing more such examples on Grignard reagent.